Well, here we are once again. Today we're going to talk about Mr. D's amplifier here. He's got himself a 1x4 bass unit, and as soon as I opened the tin, there was one thing that jumped out at me. I don't know. It looks like somebody tried to take the driver transistor in and out, and the solder work on it was a little iffy. So here, I'll show you a picture. So he's wanting me to convert this to a straight 4-pill, which we're going to do here in just a second. But I wanted to see what the deal was because he wanted me to check the driver section in this box first. And so what I did is I went in and I reflowed all the solder around the tabs. As you can see, this tab, that tab, and that tab. So the base emitter and the collector tabs. I resoldered those down, made them nice and smooth and clean. And I've got good news for you. The 1-pill driver section works beautifully in this thing. Now, Mr. D, the other thing I was telling you that I'd really am insistent that we do before the thing even leaves here is that we have to put some kind of ground fault protection inside the amp. So I'm going to drill a hole back here next to the voltage remote jack that's right here, and I'm going to put a fuse in, which is going to be about a 15 amp safety fuse. It's very important that we have that. Otherwise, if there's a short, let's say something happens down in the future with the transformer, or one of these wires rub their way through and short out, you have to have something other than the breaker panel in your breaker box protecting the electronics and protecting your home in the amp. So I'm going to go ahead and put a safety fuse in. Now, I was looking at this plug pretty close because it is so big. If you notice, in comparison to the other things that are here, it's almost twice the size. That might have an internal fuse in it or a spot for a fuse. It does not. So we're going to add a fuse. We'll put a fuse here. We're going to run a wire from here. So we'll take this wire and feed it back, and we'll heat shrink it and put another piece of wire that comes over here to the fuse, and then another wire that comes back to the switch. The other thing I wanted to talk to you about real quick is I'm really surprised you haven't had a hard time talking through the box. I noticed when I hooked it up and I tested it, what was going on with it was when I went to fire down to show drive from the 2950 going through the amplifier, I was noticing that half of my wattage was missing, and that the input reflect on this thing was through the roof. Now let me explain to you all, everybody, what I'm talking about. If you take RF and you put it in through the input jack, the RF's got to come through, go through a little piece of wire, go through the coax connector, or go from the coax connector through a little piece of wire, through a contactor, through another contact, through a little wire, through the relay, back up, through another tab, out another tab, and now it's got to go across this long length of wire over to the preamp, back across this long length of wire, back through this connector, back through, back around, and then comes back out and goes back across. Well, there's a lot of induction in that circuit, a lot of unbalanced wire, and the impedance bump from coax connector to coax connector can cause you to have a higher SWR, otherwise higher standing wave ratio, or higher reflected power, because the circuit is an imbalance for 50 ohms. So two things that affects. Primarily your receive, and secondary, if you ever shut the box off and try to talk with an amp through this, you're going to have problems. Now, knowing that you're wanting me to convert this to a 4-pill, just a straight 4-pill, you're wanting me to disconnect this 1-pill section, which we're going to do. I'm going to take this coil, I'm going to solder it down here to ground, and I'm going to take this piece of coax and move it over here and change this value of cap. Knowing that you're going to do that, you're wanting me to do this, that means that you're going to run a 150 watt, 200 watt radio into this box. Well, if I put a 7 watt radio into this 7 bird watt and about 20 PEP, if I put a 7 watt radio or a 20 watt radio into this and I'm getting over half my wattage back just trying to talk through it, when you don't have the amplifier on and you just fire down with a 150 watt or 200 watt radio, you're talking about almost a full third of that wattage coming back to your radio. And that's just from the circuitry inside of here. So now it's a simple fix. It's a very simple fix. We just got to add a capacitor, okay? And that'll bring that down. It'll make the RF and your equipment that you attach to it think everything is in tune, because it would be. And the RF will pass from this connector to this connector much smoother. So let's go over here to my little expensive grid dip analyzer. That's one of the things this network analyzer does. Now what it just did there, we're going to tell it to go into run mode. Okay. This side of the scale, you guys, is standing wave, obviously. So 1, 2, 1 point, or 1, 1.2, 1.5, 2, 3, 5, and 10. Now I can change the scale on how that reads. But now what we're looking left to right on is our frequency width. How wide of a frequency span am I looking at? You know, you get your MFJ, and as you're dialing on the knobs on the MFJ, it just shows you that one specific frequency. This shows you the entire band. Like right now we're reading from 29 megahertz all the way down to 24 megahertz. And I can change that span as wide as I want. And what we're looking at is the overall reflected signal from this coax down to this terminal, through the relay, through the preamp, and back to this terminal, through this coax to the dummy load. Let me show you what we're looking for ultimately. I'm going to pause that. We're going to disconnect the coax from the top of the analyzer. We're going to screw this coax in, and now we're going to tell it to run. That's what we're looking for, is a low response. And see how that's linearly smooth? If we go down in frequency, lower down in frequency, because my Bird 10,000 watt dummy load is a 2 through 30 megahertz dummy load. Okay. They've gone in on an overall across the spectrum. They've made a 50 dB attenuator. Well, as we go higher in frequency, now we're coming to the maximum operating range of the dummy load. So like I said, at the top end, which is this number, which is the green cursor marker, M2, is 29.52. So even all the way over here we have a 1.15. So let's pause this again. Let me hook the dummy load back up to the box. We're going to tell it to run again. So right now it's got an SWR of 2.86, and that's right here dead center. That's at 27.036111. So here, we'll move that to channel 20 or something. Somewhere right in the middle of the band. There you go. Channel was at 27.1 or 2138389.5 megahertz, whatever. Right in the middle of the CB frequency. That's a little high. Is it completely deplorable? No. Would you notice a decrease in receive? Yes, very much so. So first we're going to fix that, and then well, hold on. I got to run it through its lap. So let's do a quick little test hit on it and show you what we've got. All right. So what I got hooked up is a 2950. The RF that comes out of the 2950 goes into this Bird watt meter right here. It comes in this side, goes out that side, and the needle is reading in reverse. The slug, the actual line coupler, is reading in reverse, so whatever this moves forward shows us our input tune. So now the RF comes down, goes through this piece of coax, goes in here, goes through the relay, goes through the preamp circuitry, and out here, and then goes around and goes to the dummy load. We're using a 1000 watt slug in PEP, 1000 watt slug in Bird average, 5 watt slug in reverse. Back from the Bird 10,000 watt dummy load. So let me show you a real world application. Let's check this out. Hello, audio. Each one of these boxes represents 10 watts worth of drive. Hello, audio. Here's our input tune. Hello, audio. Now, 1 watt doesn't seem like a lot, right? Now we've taken the amplifier out of the equation, so it comes directly from the radio into the meters. Hello, audio. Hello, audio. Hello, audio. Okay. Seen double the amount of watts. Period. It's because a lot of it's getting lost in the circuitry inside the amp. Okay, let's do our baseline test. All right, and what we've done is we put the coax back into A and then back into B. So now we know what we got going on for drive. So now we're going to go and we're going to click this down into the low position. Hello, audio. Audio. So going into the amplifier in the state of operation, it's showing us about 1.25 watts worth of input reflect. Our output power, we're seeing roughly 700 PEP and about 125 P or average. Let's go to the high setting. Hello, audio. Burying it in a corner. Hello, audio. So just about 300 bird. And once again, our input tune. Hello, audio. About 1.5 watts. It is what it is. So let's see what we do on a peak scale. Let's go up to 2x here. Hello, audio. About 1200 watts. Remember guys, between the 40 and the 60 is that big hash mark, that's 1,000 watts. Hello, audio. Works good. A meter to voltage, I mean, let's look at it guys. This guy does pretty work. He does. Just some small things that are off and we're going to fix those. Not a big deal. Meter to voltage, this thing floats at about 21 volts and full tilted out drops down to about 16.5, 17 volts. So, Mr. D, the fuse, it's a must. It's an absolute must. And get the pass-through tune working so you can hear better. I mean, that'll cut your receive by half the way it was set up. So we'll get that working so we can talk through it relatively well. And then we're going to go ahead and modify this. We're going to bypass this. So also what I just showed you is that this section is working fine. I'm going to go ahead and bypass this, disable this 1-pill driver, bypass this, hook it up, make it a straight 4-pill, get the input tune set correctly, and then we'll be back to do a wrap. Just getting ready to drill the hole in the back of the cabinet. I was sitting here thinking about where I wanted to place it to where it looks symmetrical and pretty. And that's when I noticed light coming down through the fins over here. I'm like, wait a minute. Oh shit. Got a big old hole down there between the exhaust port in the cabinet and the heatsink. So I'm going to pull this cap out of the way and I'm going to build a little piece of phenolic board that will attach to the heatsink and down to the body of the cabinet that'll block this hole up, which is going to force all the air to wrap and have to go through the heatsink to exhaust out the cabinet. Just a simple little fix, not a big deal. We're going to bang that out also. I just wanted to show you that so I can have a before and after. No fuse, no breaker, we'll get this fixed up real quick. Not a big deal. Another little quick thing I noticed. Let's look down here real quick. You see this wire here? It's laying against the output wire. So all you receive and all you transmit, all full 1300 watts going out, runs right by that wire. That is your positive connection to your external voltmeter supply or source. And there's no ferrite on it. So we're taking a wire and we're laying it right next to the transmission line. Actually, they're touching. And there's no blocking on this. So I don't know if you've got a meter hooked up to this or not, but this will cause you to have false voltage readings. That's one thing that can happen. And the other thing that can happen is with 1,000 some watts going through this little piece of wire, it can actually jump through the insulation and cause a short. So what I'm going to do is I'm going to remove this wire. I'm going to take it off. I'm going to relocate it, and I'm going to put a ferrite blocker on it to help isolate the external meter source just a little bit. So other than that, between that and the pass-through and those kind of things, pretty straightforward. Very clean build. And other than some very small tuning issues, it shouldn't be that big of a deal to get going. So, back at it. Here we go. Okay, so I took the cap out, and I went ahead and I put an isolation bead on the positive rail for the external meter control. And I rerouted the wire. I grabbed some purple wire I had, and I rerouted the positive lead around the outside of the cap so we can isolate this amount of area around the output wire. The other thing I did is I went down in there and I added a blocker. So that'll force much more air to go down and come out. It's got to go down and go around and come out through the heatsink, which will help for better cooling. Even though this is built on a 2x6 board, which is oversized, which is beautiful, that'll help it even more. Okay, so I'm going to put this mess back together, and I'm going to add the fused link. Or not fused link, but the actual fuse. So, on to the next step. Okay, so we added some caps in the right places. And let's take a quick look for here what we got going on. Yeah. Tell it to run. So we're down from a 3 point whatever it was, 3.2 or 3.1 or whatever it was. You're gonna rewind the video and go and look. Down to a 1.127 going through the amp, which is huge. And when we're talking about little tiny millivolts from the receive, actually RF coming back from your antenna, that's a huge difference. Huge difference. So now we got that little problem lined out. We're going to go ahead and we're going to disable the 1-pill driver section and make it a straight 4-pill. Oh, and I added a fuse. This is a 15 amp fuse. There will be a label on the back of the cabinet noting that. 15 amp fuse. We didn't change any of this other wiring up here. We just added a wire here, and then we heat shrinked and then added another wire here, and added a safety fuse to make it safe. So okay, let's do the other bit. We'll be back. Okay, we're back. See if I can get my dog not to whine or carry on in this take, huh? What do you think, Tesla? Will we go for daddy? No? Okay. So, what we did is we disconnected the 1-pill section completely, soldered down this coil so it wouldn't be flopping around. And if ever in the future you want to reattach this coil here and move this wire over and attach it here, you'd be off to the races and running. Move the wire around. I also added some capacitors in some other spots to get the input tune to lay down, so when you actually go into operation, the input tune doesn't jump up like it was doing. And got it pretty well squared away. So in all fairness, I jumped back over here to the 2950 because I was using the Connex 4400 as a high drive radio, which we're going to use here in just a minute. So that's a 1000 watt slug in PEP, 1000 watt slug in average, 5 watt slug in reverse. Back from the Bird 10,000 watt dummy load, 5 watt slug in reverse between the 2950 and what was the 1x4 and is now a straight 4-pill. So we're going to show talking through the box. Hello, 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 hello. Hello, 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 hello. Now we're coming up our full 2 boxes, so 20 full watts. And look at our reflect. Hello, 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 hello. Trust me, drive radio will be much, much happier. We're going to put the thing down on low. Hello, 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 hello. Less than a half a watt of input reflect. Hello, audio. About 480 watts PEP. Let's show the bird. Hello. A little bit more than what we were getting beforehand. We're going to put that on high. And remember, this is only with 20 watts of drive, you guys. Hello, audio. Hello, audio. Hello, audio. Hello, audio. That's it. Done. Done. All right, let's drive it up. Just give me just a second. We'll hook up the Connex. All right. So we got the Connex hooked up. So we're going to shut this off. I'm going to demonstrate to you drive here real quick. Just charge that capacitor inside this thing. Hello. Hello. So we'll put about 125 watts PEP. Hello. And about 35-40 bird into it. So we'll start out on low. Skipped a step. Bad BBI, bad. A lot of people are going to watch this video because of the name on the amp. It's talking through the box. Okay. Put that down on low. We're on low. 120 watts of drive. Audio. 300 bird. About 980 PEP. We're going to go to high, which is going to increase the power on the amplifier on the internals. Let's see, from 12, 13, 14, 15, 16, 17, about 5-6 volts. Audio. Audio. About 420 bird, and bearing a PEP scale. We're going to put that up in 2x position. Audio. Yeah. So 14 and some change. Audio. Audio. That's all she wrote. That's as best as we're going to be able to get her. I'm going to go ahead and put the tin on it. Yeah, let's see, I'm going to rush over and I'm going to get her sent out the door to you today, Mr. D. But I appreciate you giving me the opportunity to work on your 1x4 bass. And it's now a straight 4-pill. Stop it, Tesla. It's a straight 4-pill. And she's rocking and rolling. Everything's in balance and running right. Input tune's right, output tune's right. Happy as a clam. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com, and I want to remind everybody, it's not up to the guy that's repairing the box to talk smack. It's just up to him to repair the box. I am the most drama-free guy that there is, and I love living that way. And I am totally avoiding drama when it comes to this one particular unit. Just got the job done and get her back out the door to the customer, and that's really what people want. And I'm here to do just that. I'll see you guys. Have fun. We'll talk to you all on the radio. On to the next one. Another guy, 10-8 and straight. I'll see you. Bye-bye. Man, the more I look at this thing, the more little things I find. Not life or death or nothing, but I got to solder that eyelet. But, so I get on the phone with Mr. D, the guy that owns this amplifier, and he starts telling me that he got the box, and it lasted about a week, and then it blew up, and it started stinking so bad that he had to go put it in the garage. And so I'm looking around because I don't see anything obviously burnt, like nothing's screaming at me. None of the little 10 ohm, telltale 10 ohmers are burned, nothing. What I do find is that the sideband delay capacitor is chooched. And that's when I said to myself, we gotta ask this guy if he was talking on sideband and went out. And he goes, yeah, I was actually talking on sideband and it quit. I was like, son of a gun. So, here's the deal. There's no bias for sideband, you guys. It's full up 100% ground potential reference, so that means it is Class C full crossover. It's got the delay, but there's no bias on the input circuitry, and at $65 a transistor, very dangerous risk to take. This is okay if you're running like a half a watt radio and the relay's chattering and the dead key being so low, but you're still in AM operation. A full sideband operation, class B, you have to have a little bit of input voltage added to those input transformers to retard the signal, make it class B. So we're going to add bias to this box, and then it'll be done. So we're going to shoot a quick wrap video after it's all said and done, but I'm going to add some resistors here to do some bias, and then I'll probably put another relay back in here for the switch, to switch the bias on and off on the circuitry. Cool, right? Okay. Let's get her done, get her done, get her done. All right. Well, I think we got everything squared away. Bias is added, switched, by the way. And you know, you guys, I did a measurement. There's guys that are out there using regulators, voltage regulators, on the bias for these. And there's pros and there's cons to that. With an unregulated supply, look, what really controls your voltage that goes up and down on the bias is this diode right here and its value. The difference between high and low, the amount of input current that goes onto the input amount of current that goes onto the input transformer is 0.4 of a volt. And that's the difference between 13 volts on low or 14 volts on low and 21 volts on high, but like 17.9 volts underneath full load operation. The diode is really what controls how much voltage gets fed to the input transformer primarily. So it's not really necessary the way we run these things. It's also slightly better, as in like the component's going to see a ripple free amount of current voltage, but 4/100ths of 1 volt. So it's the difference between 350 mils worth of voltage and 355 mils of voltage. 54 mils worth of voltage. Not a lot. Not a lot. In something bigger, yes, we probably want to regulate it. But you've got bias added into this baby, and she's off to the races and running. So let's go ahead and show our drive is the same. We're going to go to high. Hello, audio. Hello, audio. Hello, audio. All the numbers are the same. The only difference is now it's able to be operated in full class B. Okay, so we're allowed the transistor to go to full cutoff mode or shut down on sideband, which is pretty straightforward. Click this up to sideband real quick. Put a new sideband capacitor in there, and yes, it's held down just the way the other one was, soldered in, then it's held down with double-sided stick tape. We're going to click on the sideband delay for you. And as we're watching this puppy run, I want you to listen to the relay clicking. Hello, my name is BBI. And I just got all the way down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nice, full delay. That's it. You guys already listened to the extra. I've already forced you to listen to all that jizz. Appreciate y'all watching. Appreciate everybody sending these things up for me to work on. I know I take forever, but man, there's a lot of stuff going on up here. I am the victim of my own creation. But it's cool and fun. Gentlemen, I'll see you bye. I'm out of here. I'm going to go eat dinner. And Mr. D, your amp will be in the mail to you tomorrow, sir.